So question 12, I express the square root of minus 12 minus 16i in the form a plus bi, where a and b are real numbers. So again, keep that in mind as you're working towards the end of this question. So you've got to express this in this form. So in other words, you say a plus bi is equal to this, minus 12 minus 16i, which of course means a plus bi to be squared is equal to this complex number, minus 12 minus 16i. So square out your left hand side, you get an a squared, twice the first by the second, plus 2abi, and square the last, you're getting b squared I squared. It's equal to that. Now, I squared is minus 1, so it's really minus b squared. So this here loses its imaginary part and becomes a real number. So you've got a squared. I'm going to bring it over here at the other beside the a squared, minus b squared, and you've got plus 2abi. That's equal to minus 12 minus 16i. So you have two equations here that you can form. The real parts are equal to the real parts, and the imaginary parts are equal to the imaginary part. So one equation is a squared minus b squared is equal to minus 12, and your other equation is 2ab. So 2abi is equal to minus 16i. So the i's are going to cancel. You've got 2ab is equal to minus 16. So solve this for either a or b. I'm going to solve it for b, for example. So I get minus 8 over a. So I now know what b is, and I can substitute it into my other equation. A squared minus, this is minus 8 over a to be squared is equal to minus 12. That's 64 over a squared. So it's minus 64 over a squared is equal to minus 12. I'm going to form a quadratic now. And again, if you can't see it, well, sorry, multiply everything by a squared. You get a, well, you have a squared squared minus 64 is equal to minus 12a squared. So if you can't see your quadratic at this stage, you can do some substitution and say a squared is equal to m. So what you have is m squared minus 64. This minus 12a squared is really minus 12m, comes across to become plus 12m. There's your quadratic that you can go about trying to solve. So m squared plus 12m minus 64 is equal to 0. Factors for m are going to be 64 is going to be 16 and 4. So to put those in, 16 and 4, and you need a plus 16 and a minus 4. So I'll just continue over here because I don't know if the camera is catching all of that. We've got m minus 4, m plus 16 is equal to 0. So solving that, you get m minus 4 equals 0, m plus 16 equals 0. So m is equal to 4, m is equal to minus 16. But of course, m is also a squared. So you do your substitution back. You get a squared is equal to 4, a squared is equal to minus 16. So that's giving you a is equal to plus or minus 2. And this is giving you a is equal to plus or minus the square root of minus 16. So you're getting a is equal to plus or minus 4i. But again, you're told that a and b are real numbers. This is imaginary number, so you can disregard that. And you can go with your value of 2. So you substitute this back into one of your equations. I'm going to substitute it into my linear equation here, which was 2ab is equal to minus 16. So I'm going to go with a is equal to 2 first of all. So that's 2 times 2 by b is equal to minus 16. That's giving me 4b is equal to minus 16, or b is equal to minus 4. And my other 2ab equals minus 16. This time I'm going to put in I've done the plus 2, and then I'm going to do the minus 2. So that's giving me 2 times minus 2 by b is equal to minus 16, which is giving me minus 4b is equal to 16, which gives me b is equal to 4. So, express it in the following form: a plus bi. So, what does that mean? You've got to substitute them in. So, this is equal to this. When it's a positive 2, it's a negative 4. So your two solutions are a plus bi, that's positive 2 and a negative 4. Or you've got a plus bi with a negative 2 and a positive 4. They're your two answers.